Most people think reheating food is just a convenience decision. Put the leftovers in the microwave, warm up what you cooked yesterday, get on with your morning. What almost no one tells you, and what decades of food chemistry and oncology research have been quietly documenting, is that for certain foods, the second time heat is applied, a chemical transformation is already underway. A transformation that does not happen the first time you cook them. That only begins under one specific condition: reheating. A 2022 analysis in the journal Food Chemistry documented that repeated heat exposure in several common food categories triggers the formation of reactive compounds that the International Agency for Research on Cancer has classified as probable or confirmed carcinogens. These are not exotic ingredients. They are sitting in your refrigerator right now. Before we go any further, a quick but important note. This channel is for general education, not medical advice, and I'm not your doctor. Nothing you hear today is a diagnosis or a prescription. Always talk with your own physician before changing anything about your diet or treatment. 4 foods, 4 specific chemical transformations, and for the adults eating them several times a week the way most people do, the risk builds quietly. 1 reheated meal at a time. My name is Dr. William Lee, and this channel exists to do one thing. Take what the world's leading cancer researchers, oncologists, and food scientists have actually found and translate it into plain language that a 10-minute doctor's appointment never has time to cover. The 4 foods on today's list are not rare. They are staples. Most are foods you have probably been told are healthy or at least harmless, and most people have no idea that heat, applied a second time, is the variable that changes everything for them. By the end of this video, you will understand exactly what the research shows and what to do instead. Before we start counting down, I need to plant something in the back of your mind. The number 1 food on this list is going to stop you cold. It appears on more senior health lists than almost anything else. It is praised by cardiologists, recommended for blood pressure, celebrated for its nutrient density. Many of you reheat it several times a week because you have been told it is one of the smartest choices you can make. What the cancer chemistry research shows about that food under the specific conditions of reheating is something almost no one explains. Stay with me to number 1. That one matters most. Before we dive in, leave your age in the comments right now and tell me, which of these 4 foods do you think you reheat most often at home? I read every comment, and your answers genuinely shape what I cover next. Here is what almost no one explains about food chemistry and cancer risk, and it is the foundation for everything on today's list. Your body handles freshly cooked food and reheated food very differently. The reason sits in a process food chemists call thermal degradation. What happens to a food's molecular structure when heat is applied a second time, often to a food whose composition has already shifted during refrigeration? When certain foods are cooked once, specific molecular bonds hold. Proteins fold in predictable ways. Fats maintain their chain structure. Compounds stay stable. But when those same foods are heated again, particularly at high temperatures, or after hours in the refrigerator where bacterial activity has already begun, some of those bonds break. And what they produce when they break is not what the original molecule was. It is something new. Something the body was never designed to encounter at the concentrations that regular reheating generates. The classes of compounds the research keeps returning to are N-nitroso compounds, including nitrosamines, heterocyclic amines, known as HCAs, acrylamide, and oxidized lipid aldehydes, specifically a compound called 4-hydroxynonenal. Each of these appears in a different food on today's list. Each is generated or intensified specifically by reheating, and each has been studied by cancer researchers not as a theoretical curiosity, but as a measurable dietary exposure with documented associations to human cancer risk. Think of it this way. Imagine a building constructed from stable bricks. Apply heat once, carefully, and the structure holds. Apply heat a second time, unevenly, after the bricks have already shifted overnight, and some of them fuse into an entirely new compound the original architects never intended. That is what happens at a molecular level inside these four foods when you reheat them. The risk from any single reheated meal is not catastrophic. What the research tracks is the cumulative pattern, meals prepared this way week after week, year after year. For older adults eating these foods regularly, the conversation is overdue. Let us count down from 4 to 1. Number 4. Processed meats, bacon, sausage, deli slices. Number 4 is processed meat, the bacon you cooked on Sunday and slid back into the skillet on Monday morning. The sausage links from a large weekend batch reheated through the week. The deli turkey run through the microwave because it came out of the refrigerator cold. If you reheat these without a second thought, I need you to pay close attention, because this one does not run a single carcinogenic pathway when reheated. It runs two simultaneously, and most people only ever hear about one of them. Here is what happens inside processed meat the second time it meets heat. These products contain sodium nitrite, a preservative that extends shelf life and maintains the pink color you associate with bacon and cured sausage. When sodium nitrite encounters high heat, particularly in a food whose proteins have already been partially denatured during the first cooking cycle and refrigeration, it reacts with degraded amino acids to form N-nitroso compounds, the family of chemicals more commonly called nitrosamines. These are among the most studied dietary carcinogens in the scientific literature. That is the first pathway. The second runs alongside it. High heat cooking of any muscle protein, and this includes every reheating session in a hot pan, generates heterocyclic amines, or HCAs, and polycyclic aromatic hydrocarbons, or PAHs. Both form more aggressively on second heating because the surface proteins have already undergone structural breakdown during the first round of cooking, making them more chemically reactive when heat is reapplied. Think of it like striking a match on a worn strip. The second strike catches faster, with less friction. The evidence on processed meat and cancer risk is among the most definitive in the field. In 2015, the International Agency for Research on Cancer, the cancer classification arm of the World Health Organization, reviewed data from more than 800 epidemiological studies and formally classified processed meat as a Group 1 carcinogen, meaning there is sufficient evidence in humans that consumption increases colorectal cancer risk. A meta-analysis published in the International Journal of Cancer found that each additional 50 grams of processed meat consumed daily was associated with approximately an 18% higher risk of colorectal cancer, a figure that rises when habitual reheating adds additional HCA and nitrosamine load to each serving. What to do instead? If you cook bacon or sausage, cook only what you will eat immediately. If you must store and reheat, use low heat in a covered pan with a small amount of water, never a second high-temperature browning cycle. The steam method keeps the temperature below the threshold where nitrosamine formation accelerates significantly. And if you are on blood pressure medications or have been advised to limit sodium, discuss any changes to your processed meat intake with your physician first. That is number 4. The next one surprises nearly everyone because it is a food almost universally considered safe, even bland. Before we continue, I have to ask you something. How many medications are you currently taking? 2? 5? More than that? Because what I'm about to share with you in the next few minutes, the research on how these common drugs affect the aging brain, is exactly why the team at Senior Insight Press put together a complete guide called Pill-Proof Memory. It covers all 9 medication categories we're discussing today, in far more detail than I can give you here. It includes the specific questions you need to ask your doctor, a 90-day brain rescue plan, and a printable checklist you can literally bring to your next appointment. The link is in the description. It's from Senior Insight Press, the same people who bring you this channel. And right now, it's available at the early access price. Now let's keep going, because the next medication on this list is one most people would never suspect. Number 3. Potatoes and starchy foods. Number 3 is potatoes and bread, and any starchy carbohydrate that has already been cooked once and is reheated in a dry heat environment. An oven, an air fryer, a toaster, a skillet without liquid. The compound to understand here is acrylamide. It forms when starchy foods rich in the amino acid asparagine are exposed to dry heat above approximately 120 degrees Celsius, roughly 248 degrees Fahrenheit. The reaction responsible is the Maillard reaction, the same process that browns bread, crisps a potato, and produces the golden surface of a roasted vegetable. At those temperatures, asparagine reacts with natural sugars in the starch and produces acrylamide as a byproduct. The first time you bake, roast, or fry a potato, acrylamide forms along the surface and inner edges. The second time you run that potato through a hot oven or air fryer, particularly if you are trying to crisp it back up, the same browning chemistry is applied to a food whose water content has already been reduced and whose surface proteins have already partially broken down from the first round of cooking. The result is a higher concentration of acrylamide per gram than the first cycle produced, because the food is now more chemically primed for the reaction. Think of it like firing a clay brick twice. The first firing shapes and sets it. But if the composition of the clay has already been altered by the first heat, the second firing produces something chemically different than what the original firing intended. The International Agency for Research on Cancer has classified acrylamide as a Group 2A carcinogen, probably carcinogenic to humans, based on strong animal data and a growing body of human evidence. A meta-analysis published in the European Journal of Nutrition in 2018, pooling data from 19 prospective studies, found associations between higher estimated dietary acrylamide exposure and elevated risk of endometrial, ovarian, and kidney cancers in non-smokers. The levels that carry meaningful risk accumulate over years of regular consumption, not a single meal. But for adults who routinely reheat roasted potatoes, run toast through the toaster twice, or re-crisp hash browns in a hot pan, the weekly acrylamide load is consistently higher than it needs to be. What to do instead? Do not reheat starchy foods in a dry heat environment. When reheating a cooked potato, use a microwave or a covered stovetop method with a small amount of water. Steam does not trigger the Maillard reaction the way dry heat does. It keeps the temperature below the acrylamide formation threshold. When cooking starches for the first time, aim for pale golden, not dark brown. And if you air fry frequently, know that the combination of high heat and short cook time on already cooked starchy leftovers is exactly the environment that generates the most acrylamide. That is number 3, 2 down. The next one does not get nearly enough attention. And when you hear what the food chemistry literature actually says about it, I think you will understand why I felt it needed to be on this list. Number 2, cooking oils, especially vegetable and seed oils. Number 2 is an oil, specifically any cooking oil that has been heated once in a pan and is then reused for reheating food, or any oil applied to leftovers being crisped in a skillet. For most households, this is the olive oil or vegetable oil used regularly. For others, it is the oil remaining in the pan from last night's dinner, which is heated again this morning to warm up what is left. This one does not appear on most popular food safety lists. And when I look at what the food chemistry research actually documents about reheated cooking oils, I think it deserves to be discussed far more directly. Here is what happens when a cooking oil is heated a second time, particularly at high temperatures. Most common cooking oils, sunflower, corn, canola, standard vegetable blend, are rich in polyunsaturated fatty acids. These fats are relatively stable during a single, moderate temperature cooking cycle, but when the oil is reheated, especially if the first round reached high temperatures, the polyunsaturated fatty acid chains begin to oxidize. They break apart into reactive fragments called aldehydes. The two most studied are 4-hydroxynonenal, known as 4-HNE, and malondialdehyde, known as MDA. Both are classified in the biochemistry literature as reactive aldehydes with mutagenic properties, meaning they have demonstrated the ability to damage DNA. 4-HNE in particular has been extensively studied in relation to cellular oxidative stress and the upstream conditions associated with cancer development. These compounds are not present in meaningful concentrations in fresh oil. They accumulate specifically when oil is heated, cooled, and heated again. The analogy here is a rubber band pulled under stress. Pull it gently once, it holds and recovers. Pull it hard a second time, especially after it has already been partially fatigued. It frays at the molecular level. Those frayed ends are the reactive aldehyde fragments that your food absorbs when you reheated in used oil. Research conducted at De Montfort University in the United Kingdom and discussed in reporting by the British Medical Journal found that common vegetable oils, when reheated to typical cooking temperatures, produced aldehydes at concentrations substantially higher than their fresh oil baseline. Sunflower oil, corn oil, and blended vegetable oils showed the highest aldehyde output under repeated heating conditions. Oils with higher saturated fat content, such as refined coconut oil or butter, produced far fewer reactive compounds under equivalent conditions because saturated fatty acid chains are more heat stable than their polyunsaturated counterparts. What to do instead? Never reuse cooking oil from a previous session. If you are reheating food that was originally cooked in oil, do not reheat it in the same oil. Use a clean small amount of a more heat-stable fat, butter, ghee, or refined coconut oil, or use a covered steam method with water to warm food without adding oil at all. If you smell oil beginning to smoke during reheating, remove the pan from heat immediately. Smoke is the visible signal that breakdown is already occurring. And if you have been advised by your physician to limit saturated fat intake, discuss any change in cooking fat with them before switching. That is number 2. And now, the number 1 food on this list, the one I told you about at the beginning, the one most people consider a health food and reheat regularly without a second thought. Number 1, spinach and nitrate-rich leafy greens. Number 1 is spinach, and it shares this position with other high-nitrate vegetables: beet greens, chard, arugula, celery, and kale. Foods that appear on virtually every senior health and longevity list. Foods recommended for blood pressure management, cognitive function, and vascular health. Foods that are eaten fresh or cooked once and consumed immediately, genuinely beneficial. The problem is not spinach. The problem is what happens to spinach when it is cooked, refrigerated, and reheated. And if this describes your meal prep routine, cooking a large batch of greens on Sunday to eat through the week, please listen to this one carefully. Here is the chemistry. Spinach is one of the highest dietary sources of naturally occurring nitrates on Earth, roughly 250 to 450 milligrams per 100 grams of raw leaf. In fresh spinach, those nitrates are stable and largely beneficial. Your body uses dietary nitrates to produce nitric oxide, which supports arterial flexibility and blood pressure regulation. But here's what changes the moment spinach is cooked. Bacteria naturally present in and on the leaves begin converting those nitrates into nitrites through a process called nitrate reduction. This conversion accelerates during refrigeration as the bacteria continue their activity even at cold temperatures. When cooked spinach is then reheated, and particularly when it is reheated a second or third time over a week of meal prep, 2 things occur simultaneously. The refrigeration period has extended the nitrate to nitrite conversion further than a single cooking cycle would. And when the nitrite-rich food is exposed to high heat again, in the presence of secondary amines that are natural components of the eggs, protein foods, or other ingredients typically served alongside spinach, the conditions are established for the formation of N-nitroso compounds, the same class of chemicals that includes dietary nitrosamines. Think of it this way: fresh spinach is a river running clean. Cook it once, and you set the conditions for one chemical to slowly convert into another downstream. Refrigerate it overnight, and the conversion continues in the cold. Reheat it the next morning, and the downstream compound, now present in higher concentration, is given the exact environment it needs to complete its transformation, high heat, an acidic protein-containing food environment, a second thermal cycle. The result is a food that looks identical to what you cooked the night before, but carries a meaningfully different chemical profile. The nitrosamine pathway is not speculative food chemistry. It is one of the most extensively documented areas in dietary carcinogenesis research, studied across decades and across institutions in Europe, North America, and Japan. Research published in the European Journal of Nutrition examining habitual dietary N-nitroso compound exposure found significant associations between high dietary nitrosamine intake and elevated risk of gastric and colorectal cancers, with the highest exposure groups showing approximately a 36% higher risk compared to the lowest exposure groups across several large prospective cohort studies. This does not mean a single reheated portion of spinach causes cancer. It means that for adults building a weekly meal prep habit around reheating high nitrate greens multiple times, 4-5 times per week, 52 weeks per year, the cumulative dietary nitrosamine exposure is a pattern the research takes seriously. What to do instead? Eat spinach and other leafy greens fresh, or cook once and eat immediately. If you wilt spinach in the evening, eat it that evening. Do not store it warm, and do not reheat it the following morning. If you meal prep vegetables, store leafy greens raw and cook only what you need per meal. This single change preserves every nutritional benefit spinach has to offer: the nitrates, the folate, the magnesium, while eliminating the nitrate reduction and nitrosamine formation pathway entirely. If you take anticoagulant medications that interact with vitamin K, which is present in high concentrations in leafy greens, discuss any change in your greens consumption with your physician before adjusting your intake. Let me tell you about a woman I will call Barbara, 71 years old, recently retired, genuinely health conscious in a way most people would consider exemplary. She did not eat fast food. She avoided processed snacks. She had built what she believed was a near-perfect meal preparation routine. Every Sunday, Barbara sautéed a large batch of spinach with garlic and olive oil, 4 cups of cooked greens, enough to portion out across her meals for the week. She stored it in a covered glass container in the refrigerator. Every morning, she reheated a portion in the microwave alongside her eggs. She had done this for 3 years. She was proud of it. Consider a pattern like Barbara's. In a single week, she was reheating high nitrate leafy greens 4 to 5 times. She was occasionally rewarming turkey sausage in the same pan. And when she ran out of fresh oil midweek, she would add her eggs to the pan she had already used and let it heat through the residual oil from the previous morning. 3 items from today's list, stacked into a single meal preparation routine, repeated 52 weeks a year. When she sat down with her physician for a routine dietary review, the conversation was not alarming. It was clarifying. No single choice was catastrophic in isolation, but the cumulative pattern, repeated reheating of high nitrate greens stored over several days, residual cooking oil reused in the same pan, and processed meat warmed from refrigeration, produced a dietary exposure to reactive compounds substantially higher than she had any reason to suspect based on the foods themselves. She was not told to stop eating spinach. She was told to change when she ate it. She now prepares fresh greens in the portion she needs for each meal. She uses a clean, small amount of fat each time she cooks. She has moved to sliced fresh turkey. She cooks per serving rather than reheating sausage. The foods are the same. The method is different. The science behind what she learned had been in the literature for years. What was missing was someone connecting it clearly to a routine that on its surface looked like excellent health behavior. That is what this channel is here to do. Let me tie all 4 of these together because they share a single governing principle. The foods are not the enemy. The method is: processed meats intensify their nitrosamine and HCA burden on second heating. Starchy foods produce more acrylamide when reheated in dry heat above 120 degrees Celsius. Cooking oils generate reactive aldehyde compounds when their fatty acids are oxidized through a second heat cycle, and spinach converts its natural nitrate pool further toward nitrite and then toward N-nitroso compounds, with each additional pass through heat after an overnight refrigeration period. None of these foods needs to be removed from your plate. What the research points toward is changing the preparation habit. Cook once, eat immediately, and where these four categories are concerned, avoid the reheating conditions that generate the most reactive compounds. One line I want to state clearly before we close. Nothing in this video is a reason to make sudden dietary changes on your own, especially if you are managing chronic conditions, on medications that interact with dietary components, or following guidance from a physician about your specific health history. The right move is to bring this conversation to your next appointment. Ask about dietary N-nitroso compounds. Ask about acrylamide and your cooking method. Ask about oxidized cooking oils. Those are conversations your doctor can contextualize against your individual situation. Here is tonight's plan. 5 steps, starting now. 1. The next time you plan to cook spinach or leafy greens as part of meal prep, cook only what you will eat in that sitting. Store the raw leaves, not the cooked portion. 2. If you cook bacon or sausage, cook per meal. If you must rewarm, use low heat with a cover and a small amount of water, never a second high heat browning cycle. 3. Never reuse cooking oil from a previous session. When reheating food in a pan, use a small fresh amount of a heat-stable fat or use a covered water steam method entirely. 4. When reheating potatoes or any starchy food, use the microwave or a covered stovetop steam method. Reserve the oven and air fryer for the first round of cooking, not the second. 5. Write down these 4 categories and take the list to your next medical appointment. Ask your physician whether any of these changes make sense, given your specific health history, medications, and dietary pattern. Now I want to hear from you. Which of these 4 foods do you reheat most often? Just drop the name in the comments. That is all. Your answer may be the detail that helps the next person who reads it understand their own routine. And if this video connected something no one had connected clearly for you before, share it with one person in your life who meal preps or regularly reheats their food. That is the most useful thing this channel can do. Before you go, there is one more area of the kitchen that the cancer research keeps returning to, and most people never think about it because the risk is invisible. It is your cookware. The pots and pans you are cooking these foods in are releasing their own compounds when heated, and for certain pan types, the evidence is more direct than most families realize. That is the next video. I will show you exactly which cookware the research flags, which is considered safe, and the single swap most households can make in an afternoon. Watch that one next. I will see you there.